Okay. So a continuous random variable, guys, has an infinite number of possible values that can be represented by the interval on the number line. For example, hours spent studying in a day. It could be 3.5 hours, 3.25 hours, 3.7 hours, 3.8 hours, infinite possibilities. But if I tell you guys number of chairs in a classroom, you don't have infinite possibilities here. You can count them, 1, 2, 3, 4, 5, 6, 7. So that's different here. When we talk about time, time is continuous as well. And the time spent studying in a particular day can be any number between 0 and 24 hours. And there are infinitely many possibilities there. What is the normal curve, the bell-shaped curve, which you have already, just a glance, just at it from chapter 2. It is the most important distribution that you will learn, which is the bell-shaped curve, which is called normal. Normal curve means bell-shaped. Let me write it down here. And remember, guys, the mean is right in the center here of the bell-shaped curve. Let me just move this a little bit further. The mean is right at the center, which is the median, which is the mode, but we only care about the mean here. And the graph of a normal distribution is called the symmetric or bell-shaped curve. So this is what a normal distribution looks like, guys, which is a symmetric distribution. Mean in the middle, 3 standard deviation to the right, 3 standard deviation to the left. That will cover 99.7% of the distribution. Okay, can someone help me complete number 1, properties of the normal distribution, which we already did before? The mean, median, and mode are what? What would be the word? Anyone suggest a wording here?
Same.
Same?
The same.
Yeah. Or equal if you like. Exactly, that's one property. The normal curve is bell-shaped and symmetric about the mean. Half of it is to the left of the mean and the other 50% is to the right of the mean. Keep that in mind. The total area under the curve is equal to what? What's the number, guys? What's the total area under the curve? Always.
You mean the 3 points to the left and right?
Everything. What's that total area? As a percent, if you like.
With the outside or without?
Everything.
Everything is 100.
100%, exactly. Sum of all probabilities, guys, is always equal to 1. Remember that. Now, within 3 standard deviation, we pick 99.7%, but what I'm asking about is the entire area under the curve. It's 100%. Okay. The normal curve approaches, but never, if you remember from chapter 2, never what? It approaches the horizontal axis, but never what?
Extends.
Never touches the x-axis.
Touches.
Yeah, that's what I say. So actually, guys, if I do the normal curve by hand, this is how I sketch it by hand. Watch. See, they don't touch. They're very close to the x-axis, but they don't touch. But when you use technology, it's almost impossible that it doesn't touch. It has to do it, to make it very close, you're gonna see. If you use magnifier here, you'll notice that they're not touching, but they don't touch. All right. The x-axis, it extends further and further away from the mean. Let me show you some examples of the normal curve. When you see a curve, guys, that is very narrow, the standard deviation will be small because the values will be very close to the mean. When you see a normal curve that is flat, and so then you can say the data is more spread out and the standard deviation is large in this case. And let me show you some examples of normal curves. Look here. The mean is 3.5 here. But look at the standard deviation is 1.5. Now look at this one here. The mean is 3.5, but smaller standard deviation. And you should agree with me, it's a smaller standard deviation. Look at the data here, how widely it is spread out. And look here, they're very confined, together. So smaller standard deviation. If you look at this one, the mean is 1.5. But it has the same standard deviation as this one. So it is possible for two normal curves to have the same standard deviation, different means. And it is possible for two normal curves to have the same mean, but different standard deviation. So these are just examples of the normal curve. So a normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line of symmetry. So the mean is right in the middle, guys, always in the middle. And the standard deviation describes the spread of the data. Smaller standard deviation means the curve is very narrow. Larger standard deviation, the curve is very open, just like this one. Watch, guys, and look, compare it to that one. Okay. Now I'm gonna just ask you this exercise. Which curve has a greater mean? Which one has a greater standard deviation? You should be able to tell by just looking at the figures, and let me show you. Okay. Which curve, guys, has a greater mean? A or B?
A.
A, and you guys know why, because the mean of A is 15 and the mean of B is 12. Which curve has a greater standard deviation without knowing what the standard deviation is? B or A?
B.
B, obvious, guys, because it's look at the curve, how flat it is. So B has greater standard deviation. And you don't need what the standard deviation is, just looking at it. All right. Now, let's take this example right here. I'm gonna make the mean, let's say 100. I'm gonna make a standard deviation to be 10. So we're gonna go 3 standard deviation to the right, 110, 120, 130, and this is 90, 80, and 70. All right. In chapter 2, guys, we learned about z-scores. If I want to change 110 to a z-score, how do I change 110 to a z-score? That means how many standard deviation does 110 deviates from the mean? Well, actually, guys, the difference between 110 and 100 is 10, and the standard deviation is 10. So it's one standard deviation. So z is 1, but I gave you a formula. I said the z-score is the value minus the mean divided by the standard deviation. So if I change 110 to a z-score, it will be 110 minus 100 divided by 10, which is 1. So this has a z-score of 1. If I change 120 to a z-score, guys, it will be 120 minus 100, which is 20, divided by 10 will be 2. If I change 130 to a z-score, it will be 3. Can you guys guess what 90 is going to be as a z-score?
-1.
-1. And this is going to be what? -2. And this is going to be -3. And what do you think 100, the mean itself, what is it going to be as a z-score?
0.
0. When I tell you your z-score on the test is 0, that's not bad news. It's the average of the class. It is 0. So these are the x values, the original values. So if I change them to a z-scores, guys, it will look like this. So this same curve, exactly this curve, if instead of using x values, if I use z values, it will be 0, 1, 2, 3, -1, -2, -3. When you draw the normal curve, rather than using x, you use z-scores. This is called the standard normal curve. So the standard normal curve has a mean of 0 and a standard deviation of 1. So a normal distribution with the mean of 0 and a standard deviation of 1 is called standard normal distribution. These two curves, guys, are exactly the same, but they're labeled differently. Here you have raw data, here you have z-scores, just using different labels on the horizontal axis. Here my horizontal axis is called x, and here my horizontal axis is called z. They mean the same thing, but they just look different. And this is the formula to change a value to a z-score. So z will be the value minus the mean divided by the standard deviation. If some of you are in doubt why 90 will become -1, let me tell you why. If you put 90 here, so it will be 90 minus 100, which is -10, guys, and divided by the standard deviation, which is 10, it will be -1. 70 minus 100, it's -30, divided by 10 will be -3, and that's what we put here, -3. So any curve, guys, any normal curve can be interpreted using this one. This is in the X mode, and this is called in the Z mode. The mean will be 0. When I tell you your mean is 0, it doesn't mean that you scored a 0 on the test. That means your Z-score is 0. And Z-score is 0 means your score is exactly the average of the class, which is the mean. Okay? Now, this is what we learned, guys, in chapter 2. And now we're going to show you that you don't need to memorize the 68, 95, 99.7% rule. Do you guys still remember what was the area between -1 and 1? This is within one standard deviation of the mean.
68%.
68%. And what was the area within 2 standard deviation of the mean, from -2 to 2? Do you still remember that value? 95%. And what was the area between -3 within 3 standard deviation of the mean?
99.7.
9.7%. No longer needed to memorize those, because you're going to learn, just how to find those values today. Okay, so now, in summary, this is the normal curve. It has a mean and a standard deviation, mean mu and standard deviation sigma. This is the standard normal curve. It has a mean of 0 and standard deviation of 1. They are exactly the same, but one is in the X mode and the other one is in the Z mode. Okay. Here's what we're gonna learn now. Let me draw the normal curve, the standard normal curve, guys. This is 0, -1, -2, -3, 1, 2, and 3. Okay. If I ask you guys to find this area here, using your knowledge from chapter 2, you should be able to find it. What is this area? What percent is this area? From 0 and down, it's 50%. From 0 and up, it's 50%. So I can tell you your answer should be less than 50%, but does anyone know what this area is?
Is it 25?
Not 25%, no. What is this area? Let me give you a hint. What is this area?
34.
34%, because it's half, 1 standard deviation to the left. Yes, you are correct, 34%. So how much is left for this one? You
Would
know,
be-
half is 50%. So if this is 34%, how much is left for the shaded one in blue?
16%.
Exactly, 16%. But guys, you don't need to think even about it, how to figure this out. It is 16%. I'm going to show you a technique now and how we can find those areas. But just to show you that if I pin at -1, we can find the answer. But if I change it, then you wouldn't be able to do it anymore. If I put it in some other location, watch guys. This is the Z. And let's say I put this area and I put the Z score to be -1.23. How am I gonna find, just this area? All I know that it is less than 50%, but what is the area to the left of this? It will be very hard, just to figure it out using what you learned so far. So there must be a technique, which I'm going to show you this technique right now, how to do it. We're going to do it 2 ways. One way using a table that will be provided to you, and the other way using technology. I'm going to start with using technology to find this area. All right. So from -1 and down, guys, it was 16%. So what do you guys think from -1.23 and down is going
I have
to
a
be?
question.
Any guesses?
I have
Yes.
a question. How do you get how do you get them exact number? Them 16%, 34%. I just don't understand it still.
Oh, the 34% came from the fact that 68% of the data lie within 1 standard deviation of the mean. So what we did, in chapter 2, from -1 to 1, we said it was 68%. So halfway through, from -1 to 0 will be 34%, which is half of 68. And since half of the curve is 50%, so a 34 plus 16 will make 50%. But no need to worry about this anymore. You're going to learn how to find those areas without even keeping track of those numbers. This is what I'm going to show you right now. So would you guys agree with me at least that this area is less than 50%? Are we in agreement with that? Yes?
Yes.
It is less than 50%, of course. Let me show you how we can use technology to find this area. Okay. And then I'm going to have to go to the table. The book uses the table most of the time. You will have the table, guys, but you can use technology all the time as well. All right. It's only one feature from chapter 5 that we'll be using in the first 2 sections. So you press second, variables, and it is number 2, guys. Oops, sorry. All right. And I'm going to explain that. So take a note, guys. Anytime I ask you to find a probability on an area under the normal curve, I'm asking you to use the normal CDF. Normal means bell-shaped cumulative density function. I need this area. Okay. Look at the calculator, guys. The calculator is asking me for a lower, an upper, a mean, and a standard deviation. Let me tell you what the lower and upper means here. The calculator is asking me, what is the lower limit of this curve? Where does it end from the low side, and where does it end from the high side? Well, I see that from the high side, guys, to the right, it ends at negative 1.23. But what do you think the lower limit is? Remember, this curve extends forever to the left like this. So what do you think the lower limit is here? And this is the upper limit.
0.
It goes beyond 0. Look, this is the 0 right here. So
Oh, yeah.
it
Mhm.
extends indefinitely. So what number would you use here, guys? It goes all the way to the left forever.
Infinity.
Infinity, negative infinity, but we're not going to use negative infinity. We're just going to pick a number. Let's use a negative 1,000,000. I tell students, instead of negative infinity, use negative 1,000,000. So your lower limit, guys, is negative 1,000,000. Your so lower is what borders the area from the left. Upper, what borders the area from the right. And then the calculator is asking for the mean and the standard deviation. Since we are using a z-score, guys, the mean is 0 and the standard deviation is 1. 0, 1, 0, 1 when you use z. Okay, so watch now. So we're going to use negative 1,000,000 here. We're going to use the upper, which is negative 1.23. We're going to put 0, 1, leave it like this, and then we're going to hit paste. And then that's the area. It's 0.1093.
Can you repeat the steps one more time?
Yeah.
Thank
So
you.
to find the area to the left of z-score negative 1.23, we need 4 values. We need the lower limit of the area. Where does this area end from the left? Since it doesn't end, guys, we use negative infinity or negative 1,000,000. Where does this area end from the right? It ends at negative 2.123. It doesn't go beyond that, guys. And then we have to put the mean of 0 and the standard deviation of 1. So this is what I did. I went to second and variables. I put normal CDF, and I provided the lower limit to be a negative 1,000,000, the upper limit to be negative 1.23, and then the mean is 0 and the standard deviation is 1. And then I put paste, and I got 0.1093. Now, let's do another one. What is the area to the left of z equals 1.15? Let me just sketch it for you guys so you can see what I'm talking about here.
I just have one more question.
Mm-hmm.
Do we always gonna use the negative 1,000,000 for the lower limit?
Yes, when you use it, you can use for a left, yeah, use negative 1,000,000. And you guys, you can guess what I like it to use for the right bound. If it goes to the right, what would that be? 1,000,000. You can put negative 1,000,000 or negative trillion or negative billion. Put as many zeros as you want. It doesn't matter. Just put enough zeros. On the calculator, he uses negative 1 with 99 zeros for negative infinity, but you don't have to use that. Okay, to the left of z equals 1.5. This is 0, guys. Put 0 here. You guys agree with me that 1.15 is on the right of 0, so it will be right here. And do you guys agree with me to the left of 1.15, it has to be this area? Are we convinced that the answer should be more than 50%? Yes or no?
Yes.
Yes, because you can see I highlighted more than 50% of the curve. Let me show you how to find it. Okay, help me. What's your lower bound here? What would be your lower bound? Lower bound is what?
Negative 1,000,000.
Negative 1,000,000. Very good. That's a lower bound. And what's the upper bound?
1.15.
Yes. And your mean is 0 and standard deviation is 1. Once you figure this out, guys, you're ready to go. Watch. Second and distribute, normal CDF. Negative a million, 1.15. And I should get an answer more than 50%. If not, I would not use this calculator anymore. Here you go, 0.8749, guys. All right, let's do a second exercise. Now we're gonna go to the right. I'm using technology at the moment. I'll be using the table just in few seconds. So we're gonna do to the right of z equal 1.23. Watch, guys. Draw the normal curve, standard normal, put a 0 here. And you guys agree with me, 1.23 should be somewhere here. And to the right, it's gonna be this area.
Could you move the paper down a little bit, please?
Yeah. Here you go. You guys, you can see the answer must be less than 50% because it's to the right of 1.23. Okay, help me. What's your lower bound? What's your upper bound here?
Lower 1 million.
No, the lower will not be 1 million. It's on the right. When you go to the right, it will be upper because you're going left and right. So that will be the lower bound. The larger number is always the upper bound and the smaller number is the lower bound. That could help you. And I agree with you, it's a million here. That's your upper bound. And the mean is 0 and standard deviation is 1. So here's how we're gonna find the area. Watch, guys. You go second and distribute, normal CDF. You put 1.23, you put a million, put a trillion, whatever, just put as many zeros as you want. It doesn't change the answer, guys. It's 0.1093. So the area to the right of Z is 0.1093. Okay, let's do one more here. Wanted to have a feel good about it before we go to the table. Okay, let's do this and that. How would you find the area here using technology? What's your lower bound? That's easy. When I give you between two numbers, should be very easy. What would be your lower bound and what would be your lower upper bound? So you guys agree that the lower bound is this
Negative
number,
1.
and that's the upper bound, or lower limit and upper limit. And look, you go to normal CDF. You put the lower bound, which is negative 1.71, upper bound, which is 1.89, 0, and 1. And that's Z again. We're doing only working with Z. So let me show you. Clear, second, distribute, normal CDF. Lower is negative 1.71. Upper is 1.89, 0, and 1. And it's 0.92.
So when do we use the million?
The million only when he says to the left or to the right. But when he says between two numbers, you don't need to use a million because he said it's confined between negative 1.71 and 1.89. So let me give you, I'm gonna have you do that now, guys. So just have your calculator ready. If I ask you to find this area now, you're gonna see a lot of questions in the homework where he shades the region and he asks you to find the area. Okay, find me this area right here. The shaded region. To the left, this is to the left, guys. When you go to the left, this way, it's to the left. When you shade to the right, then you say area to the right. So this is area to the left of Z. Equals 1.74. What is this area? Okay, I'll give you a minute to find the answer using normal CDF.
0.9590.
So we go to second, normal CDF. That's the highlight of chapter 5, guys, this formula here, -1,000,000. Even if you put -1,000, guys, it's gonna work. It's gonna give you the answer, 1.74, 0 and 1. $9,591.
I have a question about the million. So we use the -1,000,000 if it's to the left or to the right?
Yes, you are correct.
So that's to the left. If it's shaded
Okay.
to the left, then it's -1,000,000.
-1,000,000, then the number. And if it is to the right, the number
Then
and then the
it's
million.
Then it's just positive. It's to the
Yes,
right.
you got it. And which I'm gonna go do the second example to show you guys the 3 scenarios, and there are no other scenarios. Okay, guys, find me this area now. To the left, to the right of 0.74. Let's make sure you pick up the skills on the calculator and then,
Do the 1,000.
okay.
Oh,
That's a million.
I see my mistake. I did the -1,000, not positive.
Yeah. That's okay, guys. Make mistakes now. That's fine.
So is it always gonna? Are you always gonna plug in 0 and 1 at the end?
I always, when you work with Z, it's always 0 and 1.
Okay.
Because we know the mean is 0 and the standard deviation is 1 when you work with Z scores.
Okay, that's only with Z-scores.
Exactly. Once you see the question has the letter Z in it, be sure that it is 0 and 1. All right, so that's the answer. And now, let me show you guys that we could have done this using what we call tables. So I'm gonna just do this. And now probably you'll ask me why we have tables since we have technology. Well, the tables were available, were there before the technology evolved. And now we can do things on using technology, calculator or software, and they still have them in books. And I have to tell you that most of the problems in the book, when you wanna get some help, solve the problem or view an example, he's gonna be using tables. So I think it is important to learn how to use the tables in order, just to find areas. But feel free always to use the calculator since I'm teaching you how to use the calculator. Okay, let's do this. Let's do it first using technology, and then I'm going to show you how to use the table. Area to the left of Z equals -0.56. If you are to use technology, guys, you're going to go to normal CDF. You're going to put -1,000,000. You're going to put -0.56. You're going to put 0 and 1. And I hope everybody agrees with that. That's a -1,000,000 here. Lower limit, upper limit. Okay, I'm not going to find the answer yet. I'm going to take you now to this table, which you should have online, and then I'll email it to you separately. And let me show you, explain this table to you. All right. Please watch this table, guys. All right. Okay. In this table, guys, he will give you the z-score, and this table will give you the area to the left of the z-score. Look how he describes this. He says, if you provide the z-score, then the table will give you the area to the left of the z-score. Now, how do I know that it says that? Because look, the area is shaded to the left this way. So if I go back, to the question there, it says I want the area to the left of negative 0.56, guys. Watch. I need to find the z equal negative 0.56, and let me show you how to use the table to find the area. Okay, the 0.56 have two digits after the decimal point, the 10th digit and the 100th digit. You go to the first column to find the 10th digit, which is the 0.5, and look, it's right there, guys, the 0.5. Now I need the 6. The 6, guys, you will find it from the first row right there, which is right here. So you draw a line, a vertical line that drops down all the way. And then from 0, negative 0.5, you draw a horizontal line, and where the two meet will be your answer, guys. Can you tell me where negative 0.5 and 0.06 meet? At what number? See if you're reading it properly.
0.2877.
I agree. It is 0.2877. Look, guys, negative 0.5, and then look at the 6 right there. That is exactly correct. 2877, and that would be your area. And that's how, so 0.2877. The reason why I did not find the answer using technology, I want to show you that it is a match. Watch. Now let's use technology. Second, distribute, normal CDF. Lower, guys, it's going to be negative 1,000,000. Upper is going to be negative 0.56 and 0.1. Now I'm in trouble if I don't get a match here. There you go, 2877. Actually, the calculator does a better job. It gives you more decimals, but the table is restricted to 4 decimal places. So the table, guys, that you have will only do areas to the left. So what about if you have area to the right and you don't have a calculator handy, just to find this area? So let me show you how we could still use the table. So let me give you another example here. Okay, I'm going to shade this region. Let me make it like, for example, 1,4. I want the area to the right of z equals 1.14. I don't have technology. I only have the table, guys. Okay, this table has 2 pages, one with the positive z-scores and one with negative z-scores. So let's display the one with positive z-scores. Okay. Remember, this table only gives us areas to the left of a z-score, but he wants the area to the right. Any suggestions, guys? How can we find the area of z to the right of z equals 1.14 using this? Okay, this is 1.1, and this is the 4. And if you do a vertical line and a horizontal line, what number do you read, guys? Can you read this number for me?
0.8729.
But that's not the answer, guys. That is not the answer. I want you to look at the area. 0.8729, that's more than 50%. My answer is less than 50%. I know my answer is less than 50%. So the table reveals this. But remember, the table produces area to the left, but I want an area to the right. So how can I use this answer to find, just my area to the right? So we said 1.14.
1 minus the one we had.
Exactly. So if he's asking you guys to find an area to the right, you use the table as is, but then the answer that you get from the table is subtracted from 1, because what the table did for you, it gave you this area. It gives you the area to the left of 1.114. So this area, guys, is 0.8729, but I don't want this one. I want the other one. Well, we know the sum of all probabilities is 1. So your area right here will be 1 minus 0.8729. And you just do the math. So this is the drawback of using the table. You have to do some work, whereas if you use the calculator, you just set it up right, and you don't need to subtract or do anything when using the calculator. Will I require using the table? I don't, but when you do some homework problems and you need some support while working on your own, if you click on a help me solve this, you might just see the tables, and he's trying to help you, not just locating the table. So it's good to understand, just how to use the table. So in summary, guys, if he asks you to find the area to the left of a number, you just use the table as is. If he asks you to find the area to the right of a number, you use the table, but you subtract the answer from 1. And this is why a student asked me earlier, why do you have 1 minus? And let me just tell you why I have this right here. So for area to the left, guys, you just use the table as is, but look, I said use the table. Find the area to the right of z equals 1.23. So what I did here, you would find the area to the left of z equal 1.23 first, using the table. Watch. 1.23, if you can read it for me, guys, 1.23. 0.8907. And then your area to the right of z equal 1.23 will be 1 minus this one. That's what I meant by 1 minus. Do you have to do it this way? No. If you know how to use the calculator, that would be fine with me. You don't have to do this. But if you like to use the table, this is also another way to find areas under the normal curve. All right. Now, how can we use the table if we have to find the area in between two values? Let's see if students can tell me how would you do that. So for example, if I ask you to find this area, using the table. Using technology is easy. This is your lower and this is your upper. That's it, done, and you get the answer. How would you use the table, guys? Find the area between 0.35 and 1.17. There is the table. Remember, 0.35 and 1.17. What would you do? Any ideas? You could still do it using the table rather than using technology.
You would look for both and then subtract
Yep.
0.35 from the larger value.
Very good. You will find the area. Look what you do. I agree. Let me explain that to you guys. You will find the area to the left of 0.35, which is this area. Then you will find the area to the left of 1.17, which is this area. And if you subtract the two areas, guys, you will get what you want, because when you subtract, you will get rid of this. This is what we don't want. So that's absolutely correct. You will use the table to find the area to the left of 1.17. You will use that table to find the area to the left of 0.35 and subtract the two answers. And I'm going to show you that this works as well. So let's do the 1.17 first. 1.17, guys, it will be 1.1 right here, and then 7. So I got 0.8790. That's 1. Let me write it down. Minus Now we need 0.35. 0.35 is right here, guys. This is the 0.3 and just keep going until you hit the 5. 6368. So probably you would prefer technology having that will avoid you not just doing this work. So it will be 0.8790 minus 0.6368. And the answer, guys, is 0.2422. But if we use technology, watch. Very simple in between. Barely I have any students make mistakes when it comes to in between because the lower and the upper are obvious here. Okay, the lower, guys, is 0.35. The upper is 1.17. Just be careful. The lower has to be the smaller value and the upper is the larger value. And 0 and 1, and watch. Perfect match, guys. 2422. If I round to 4 decimal places, it will get 2422. So now you know how to use the table or how to use the calculator. I will leave it up to you guys to decide. I will email you links to the table. They're already available in your book, but I'll just email them separately to you. If you like to print out the table and just leave it handy. This is the table, guys. This is the positive one. And I have another page with the negative value of Z. And the maximum value of Z that you can use the table for is 3.49. So what will happen if you want to use the table and you have a value of more than 3.49? You just use 3.49. Because remember, guys, we said that the Z-score should not even exceed 3. When you go to 3, you're in the outliers at the extreme value. And that's why this table doesn't even extend beyond 3.49. And the negative 1 will be negative 3.49. Okay, so that's for using the table. I'll just go back here and go to the next page. All right. Just demonstration on how to use the table again. Find the area under the standard normal curve to the left of Z equal negative 0.99. Okay. Negative 0.99. Let me show you the table. Or let's, if you like to use technology, let's use that. So that would be normal. CDF. Can students tell me what the 4 arguments would be here? Okay. To the left of negative 0.99. What would be my lower bound, guys? Right.
Negative
Negative million.
You got it. My upper bound. Negative 0.
Negative 0.99.
And 0.1. Watch. No need to use the table. And that's it, 0.1. So I got 0.1611. But just to prove this to you guys that you could have used the table with a negative Z-score. Negative 0.99, guys. And it's going to be here. Negative 0.9. And then I need the other 9, which is right here. There you go. 0.1611. So the table is useful as well. Now, when I ask you to find the area to the left of a number, it's exactly the same thing as asking you to find the probability of Z less than that number. So an area under the curve, guys, it's the same thing as asking a probability question, a percent. So when he says Find the probability of z to the left of negative 0.99. He's asking you to find the probability of z less than negative 0.99. Here to the left of z equal negative 0.47. It's the same thing as z less than negative 0.47. Because when you go to the left, guys, of a number, you're going less. When you go to the right of a number, you're going more than that number. And that's why left means less, right means more. Okay, let's find this one on the calculator. Okay, guys, can you tell me what the arguments would be? Z less than negative 0.47. Lower doesn't change, negative a million stays. So as a student said earlier, when you do to the left of, and now you know it means less than, it's always the lower. You have to start with a very high negative number, negative a million or negative a billion. And now you do negative 0.47. And then mean 0.1 standard deviation, and that's the answer. Probability can never be negative, so it's 9.2. Okay, area to the right of z equals 1.28. Guys, we're gonna use technology, so I'm not gonna use the table here, so I'm gonna remove all of this. Okay, can you tell me what the sign would be here? So that would be what? Greater?
Larger.
And that will be, if you want me to write the feature on the calculator, will be normal CDF. 1.28 comes first, then a million, then 0, then 1. Okay, let's do it. So 1.28. Put as many zeros as you want, guys. It doesn't matter. It's gonna give you exact same answer, which is 0.1003. All right. Let's do the next one. Area between negative 1.1 and 1.73. This is how you express this as a probability. Like this. That's a between. You put the smaller number first and the larger number next. And then you run a normal CDF, guys. You put negative 1.1, then 1.73, then 0, then 1. And let's do the answer. Negative 1.1, 1.73. There you go. Turns out to be what I just put right there. And let's hit enter. 0.8225. All right. So I hope that you guys are comfortable now in how to find the probability of z greater than, less than a number, or in between. And for that, guys, I'm just gonna write a summary for the three and how to use technology with this. So just, this is the summary right here. If you guys are asked to find the probability of z less than a number, this is what you do. You do normal CDF, you put negative a million, negative a million, comma, a, comma, 0, comma, 1. If he asks you to find a probability of z greater than a, you put normal CDF, Can someone help me and tell me what the 4 arguments would be here? Don't be afraid, I'll help you out. What would be the first number?
It would be A,
Next number.
1,000,000,
You got it. And now the rest is easy, 0 and then 1. If he asks you guys to find the probability of Z between 2 numbers, A and B, it will be normal CDF, A, comma, B, comma, 0, comma, 1. As simple as that. Just put A as a lower, B as an upper, 0 and 1. So this is the rule for the TI-84. So you learn how to work with Z, guys. But in real life, we have raw data, we have X values, we have the actual values. So what about if we have X here? The actual normal curve, not to changing it to Z-scores. And he wants the area of X being less than 600, and the mean here is 500, and the standard deviation is 1. Any ideas, guys? How would you find this area based on the knowledge that you have already?
Same thing, we just replace the standard deviation and the mean.
Very good. So what she's saying, guys, you use the same thing, but instead of putting 0 and 1, you just put the mean, which is 500, and the standard deviation is 100. That would perfectly work. So to find the probability of X less than 600, it will be normal CDF. Okay. Can you guys tell me what the lower is? Right here.
-1,000,000.
-1,000,000. What's the upper? The upper
600.
is the other end, 600. It will be a fatal mistake if you put 0 and 1, guys. We're not working with Z-scores. We're working with actual X values. So we need the actual mean and the actual standard deviation. You put 0, 1, you get a totally wrong answer. Nonsense answer. So you have to put the mean, which is 500, and you put the standard deviation. Okay, let me show you. -1,000,000. Don't watch the number of zeros that you put there. That's fine. Put as many as you want, guys. There you go. 0.8413. Okay. Let me tell you this, guys. The last time I did this question, a student told me, Mr. Bazzi, can I still use the Z method here and use 0, 1? I said, yes, but you have to do one thing. What would be that thing? If you don't want to use X less than 600, you want to use Z, what would you do?
Change 600 to a Z-score of 1.
Excellent. Excellent. You change 600 to a Z-score, and now you're back to 0, 1. And I'm going to show you, you don't have to do it, guys, but I'm going to show you that it will give you the exact same answer. Or change X equals 600 to a Z-score. There is no need to do that when you're using technology. So if you change that to a Z-score, it will be, guys, 600 minus the mean, 500 divided by 100, which is a 1. So rather than finding the probability of X less than 600, guys, you find the probability of Z less than 1. Which is going to be normal CDF, -1,000,000. Instead of 600, I'm going to put a 1 because I changed it to a Z-score, and then 0 and 1 now. And watch, guys, you should get the exact same answer. If I don't get the exact same answer, then we have a problem here. But actually, this is extra work that's not needed when you're using technology. You see, guys, it's perfect match. It's the exact same answer. But you are correct about changing to a z-score. Just, I wanted to do this additional step here to show you that the table, guys, that we have makes sense, to make it easier for people to use z-scores. That's why we have the table. So in order to use the table, guys, you couldn't use the table here. There's no such a thing in the table that calls probability of X less than 600. You have to change to z-scores. So if you didn't have a technology here, the only way that you could have solved this question right here, guys, is to change the 600 to a z-score, because the table needs z-scores. It doesn't need raw, it doesn't work with actual values. You have to change any value to a z-score. And this is where the table, will become somehow important. If you don't have access to technology, you have to change to a z-score. All right, guys. So